So here we are looking at some soil here at Lamport, and what we know with the soil at Lamport, we've got a very high silt content, very high calcium content. This soil tends to run together, slump and come very tight. So we know we really need some form of tine in the soil to try and actually get some oxygen back into our soils. And we can see quite clearly here where I pulled some soil back in the bare area at around about 5 centimetres. It becomes very platy and very tight. And beneath that is actually not too bad. When we put a penetrometer in, we tend to get constantly here at Lamport, because of this vertical river of the fines going down and that build up, around about 200 psi, round about that 5 centimetre mark quite readily. And that's a real problem, because once you get between 200 and 300 psi, that's when roots really start to struggle to get through themselves. And certainly above 300 psi, most arable crops, it's game over for rooting. So this is why this needs a little bit of help to get the roots through there, and then the biopores and the natural biology will start to restructure our soils for us. So that's where we are with no soil. What we can look at now is what some crops and roots are doing there. If we take blackgrass as a start, and I'll just dig up a little bit of blackgrass here, and we'll start to look at the rooting structure of the blackgrass. And we can see quite clearly here, we're not getting much further than that 5 centimetres. Blackgrass is a really poor rooter, very sort of prostrate, and not actually going through that 5 centimetre plate that we can see quite clearly here. So people who use blackgrass as a bit of a cover crop, what we're actually finding, we're actually making the soil structure worse. It's really drying out that top and almost peeling apart. Very platy underneath, and really speaking, it's not allowing that biology to function and restructure our soils. But if we compare that to a wheat plant, and we just dig a little wheat plant out here and see what the rooting structure is from this one, we can see straight away that yes, it's a little bit platy and a little bit tight, but the roots are going through that level that blackgrass is struggling to get through. We've got roots going down to depth. Yes, it is tight because of the fines running down here, and in an ideal world, it would have been nice to have a little tine through here just to help get through some of these tougher sections, and then allow the roots to really extend and colonise, and allow the earthworms, etc., to create the biopores and the infiltration. But what that's really demonstrating, what living roots can do to our soil. So we always want to have roots in our soil to improve soil biology and soil structure.